Example number 2, section 2.5. Determining the differential equation given the problem is exact. If it is not, can it be solved? Well, let's recall that this expression multiplying d of x or dx is m, and this expression multiplying dy is n. So now we have to check first if the equation is exact or not. So the derivative of m with respect to y will be 2y plus 2x. Derivative of n respect to x is going to be simply negative 2x. So as you can see, derivative of m respect to y is not the same as derivative of n respect to x, so the equation is not exact. So what to do then? Well, we're going to try to find an integrating factor, and if we can find the integrating factor, then we can solve the equation. So let's try to find an integrating factor of the form partial derivative of m respect to y minus partial derivative of n respect to x divided by n. If we can get an expression depending only on x, then we can obtain an integrating factor and then convert the given equation to exact. So we have 2y plus 2x minus negative 2x divided by n, and n is negative x to the second. Then we have 2y plus 4x over negative x to the second. So there is no way we can simplify this expression so that we get an expression only depending on x. So does not depend on x only. So let's try a different route to see if we can solve the equation. So what about we try the partial derivative of n respect to x minus partial derivative of m respect to y, but this time divided by m. So we have negative 2x, which is the partial derivative of n respect to x, minus the partial derivative of m respect to y, which is negative 2y minus 2x, everything divided by m. M is y squared plus 2xy. Then we have negative 4x minus 2y divided by y squared plus 2xy. Then on the top, we can factor negative 2. Then we have 2x plus y. And on the bottom, we can factor y. If we factor y on the bottom, we have what? Y plus 2x, which is the same factor we have on the top. They cancel, then we have negative 2 over y. So as you can see, we have obtained an expression only depending on y. So this may work as a way to find an integrating factor so that we can convert the given equation in as an exact equation. So we have u of y because this time the integrating factor depends on y, equal to the integral of -2 over y dy, and that's e to -2 integral of 1 over y dy equals to integral of -2 ln of y, which is e to ln of y to the -2, simply y to the -2, or 1 over y squared. So this is our integrating factor. So now we can try to convert the equation, the given equation, to exact. So we have y squared plus 2xy dx minus x to the second dy equal to 0. That's the given equation multiplied by the integrating factor. We have y to the -2, which is the same as 1 over y squared, right? It is the same exact thing, 1 over y squared. So if we multiply, we're going to get a new equation that is going to be exact. And you can check that. So we have 1 plus 2x over y dx, right, minus x to the second divided by y squared dy equals 0. And then this equation is now exact, and then this expression multiplying dx is our new m, and this expression multiplying dy is our new n. And then this equation is exact now. So solving the equation, we have to compute the function f of x comma y, which is now the integral of, so since we found an integrating factor depending on y, it is convenient to compute the function in this way. Integral of nx y dy plus g of x. Okay, so that's going to be the integral of -x to the second divided by y squared dy plus some function now depending on x, right? Our function is going to depend now on x. So the integral of -x to the second divided by y squared in terms of y, well, it's convenient to rewrite this y squared as, right, bring it to the top, right? So we're going to obtain x to the second, y to -1. Remember, -2 plus 1 is -1 divided by that new power, -1. So our negative cancel, and then we have this as the form of f of x comma y. Now it's time to find, now we need to find g of x, right? To find g of x, we compute the partial derivative of f respect to x now, so that we can find g of x. So the partial derivative of f respect to x is going to be our new m of x comma y. Okay, so the partial derivative of the function respect to x, remember y now is going to act as a constant, as a number. So we have 2x divided by y, right, plus the derivative of g of x is going to be g prime of x, and then this is going to be equal to m, and the m is 1 plus 2x divided by g, same factor, I mean same term, 2x divided by y cancel, so we have that g prime of x is 1. Therefore, g of x is simply x by applying integration. So the solution is the function we found, right? Which is x is second, y to negative 1 plus x equals c, or x is second divided by y plus x equals c. Same thing.